welcome to my channel Math Made Easy. In the previous two videos I solved section A and section B and completed question number 26 in section C. In this video I am going to start with question number 27 in section C. Let's start. What is given question number 27? The sum of two numbers is 18 and the sum of the reciprocals is 9 by 40. We need to find the two numbers, right? Since the sum of the two numbers is 18, so we can assume one number as x. If we assume one number as x, then the other number would be 18 minus x, right? You have to be very careful. You may write this as x minus 18, then it is not correct. If you assume one number as x and another number as x minus 18, their sum will not be equal to 18, right? It will be 2x minus 18. Now you see, if one number is x, other number is 18 minus x, then the sum would be x plus 18 minus x. So x minus x gets cancelled. Our sum is 18, right? Okay, let's write it down. Let the required numbers be x and 18 minus x. Let the required numbers be x and 18 minus x. So from the first data we could write the numbers would be x and 18 minus, and from the second data the sum of the reciprocals is 9 by 40. Since we assumed one number is x, its reciprocal will be 1 by x plus other number would be 1 by 18 minus x. Their sum should be equal to 9 by 40. Now take LCM and simplify. LCM would be x into 18 minus x. Okay, here we already in the denominator we already have x, that means we need 18 minus x. So numerator is 1, so 1 into 18 minus x is 18 minus x, plus we have 18 minus x, so our denominator should be x into 18 minus x, that means we need to multiply by x. So x into 1 is x is equal to 9 by 40. Minus x plus x gets cancelled, then it would be 18 by x into 18 minus x would be 18x minus x square is equal to 9 by 40. So at this stage we may cross multiply and then simplify. Otherwise, to make your calculations easier, what you can do, you can cancel 9 and 18 here. 9 times 1 and 9 times 2. Now you cross multiply. 1 into 18x minus x square would be 18x minus x square is equal to 2 times 40 is 80. Now transpose. It will be x square minus 18x plus 80 is equal to 0. Now we can split the middle term by, when we multiply we need to get 80 and when we add we need to get minus 18. That means we can split it as minus 10 minus 8. So minus 10 plus minus 8 gives you minus 18. Minus 10 into minus 8 will give us 80. So it will be x square minus 10x minus 8x plus 80 is equal to 0. So it will be x into x minus 10 minus 8 into x minus 10 is equal to 0. We can take x minus 10 common, then we are left with x here and minus 8 here is equal to 0. Then so 0 product rule, since the product is 0, one of them should be 0. So either x minus 10 is equal to 0 or x minus 8 is equal to 0. So either x is equal to 10 or x is equal to 8, right? So if we take x is equal to 10, then the other part would be, if x is equal to 10, then the other part 18 minus x would be 8. 18 minus 8. So the number can be 10 comma 8, or if we take x is equal to 8, then obviously other number would be 10. 18 minus 8, which is 10. So you can divide them 10 into 8 or 8 into 10. Hope this is clear. Sum of two numbers is given as 18. So we can take the required numbers be x and 18 minus x, right? So under reciprocals is 9 by 40. So the reciprocals of this x and 18 minus x would be 1 by x and 1 by 18 minus x. Their sum. So plus is equal to 9 by 40. So you just simplify it and then you get a quadratic and split the middle term. Then you get the values of x. We get two values of x as 10 or x is equal to 8. If x is equal to 10, we get the other part would be 8. And if we have x is equal to 8, other part will be 10. Right, other number would be 10. Hope this is clear. We can also solve this in two variables also. You can assume one number as x and another number as y. Then your x plus y is equal to 18. Then 1 by x plus 1 by y is equal to 9 by 40. You can solve in that way also. But you need identities in order to solve that question. Alright, go to the next question. If alpha and beta are zeros of a polynomial 6x square minus 5x plus 1, then form a quadratic polynomial whose zeros are alpha square and beta square. Alright, there are two methods to solve this. Let's see first method. Okay, so before starting this, we'll see what is the concept we need in order to solve this question. So in general, if we have alpha and beta are zeros of the polynomial, then we can form a quadratic polynomial as x square minus of sum of the zeros into x. So here, since alpha and beta are zeros, sum of the zeros means it will be alpha plus beta into x plus product of the zeros, which will be alpha beta. Of course, k into, it can be any constant, k into x square minus of alpha plus beta into x plus alpha beta. Alright, so in this case we have alpha and beta zeros of this polynomial. So we can factorize this and then find the values of alpha and beta. And now we want a quadratic polynomial with zeros as alpha square and beta square. So since if alpha and beta are zeros, so this is the polynomial we are going to get. If alpha square and beta square are the zeros, then our required quadratic polynomial will be k into x square minus, in place of alpha we have alpha square now, so alpha square plus beta square into x. So this is the sum of the zeros plus product of the zeros will be alpha square into beta square. Right? Now what we'll do, we'll find alpha beta values here, then find alpha square and beta square, add them, then you multiply them, then you just need to substitute here, we'll get a required quadratic polynomial. This is the first method. Okay, so first factorize this. We are going to find the zeros. So equate this to 0. 6x square minus 5x plus 1 is equal to 0. So split the middle term. When you multiply, we need to get 6. When we add, we need to get minus 5. So we can split as minus 3x minus 2x. 3x square minus 3x minus 2x plus 1 is equal to 0. So we can take 3x common from the first two terms. So 3x common. So we will be left with 2x minus 1. Then minus 1 common. 2x minus 1 is equal to 0. Again 2x minus 1 is common from both. So 2x minus 1. We are left with 3x here and minus 1 here is equal to 0. Now 0 product rule, we can equate 2x minus 1 is to 0 or 3x minus 1 to 0. So either 2x is equal to 1 or 3x is equal to 1. So either x is equal to 1 by 2 or x is equal to 1 by 3. So we have our alpha is equal to 1 by 2. So let's say 1 0 is alpha and another 0 is beta. So we have alpha is 1 by 2 and beta is 1 by 3. Now we find alpha square and beta square values because we want to substitute alpha square plus beta square into alpha square beta square. So alpha square plus beta square will find first, which will be, since alpha is 1 by 2, alpha square will be 1 by 2 wholes, which is 1 by 4, plus beta square is 1 by 3. 1 by 3 square will be 1 by 9. So which gives us, if we find LCM, 36, 13 by 36, alpha square plus beta square. Similarly, alpha square into beta square would be 1 by 4 into 1 by 9, which is 1 by 36. Now just substitute this value. So the required polynomial will be k into x square minus of alpha square plus beta square into x plus alpha square beta square. So it will be k into x square minus alpha square plus beta square is 13 by 36x plus 1 by 36. So k into, we can take 36 LCM. That will be 36x square minus 13x plus 1 by 36. So bring this 1 by 36 outside. So it will be k by 36 into 36x square minus 13x plus 1. So our k can be any integer, right? So if you put k is equal to 36, so this is true for any value of k. So if you put k is equal to 36, then our required polynomial would be 36x square minus 13x plus 1. Alright, if you have any doubt how we can replace k with 36, then please mention the comment box. I will clarify it further by making another video. So this is the first method. 36x square minus 13x plus 1 is our required polynomial. Hope this is clear. We just identified, we just found out what is alpha and beta. Then we found out alpha square, beta square. Then the key concept here is that you need to know when alpha, beta are zeros, then you can form a quadratic polynomial by having x square minus of sum of the zeros into x plus product of the zeros. This is the main key thing here. Alright. Next, method 2. So here we got 36x square minus 13x plus 1. We'll write it here and cross check with other method as well. 36x square minus 13x plus 1. Okay, for this method also we need this. When alpha, beta are zeros, then the required polynomial will be k into x square minus of alpha plus beta into x plus alpha beta. Here, and the next thing also, if alpha square and beta square are zeros, then we have k into x square minus of alpha square plus beta square into x plus alpha square beta square. Only the method differs, the procedure differs in how we are finding alpha square plus beta square and alpha square beta square. That's all. Okay, so here another one more thing what you need to know in this method is that we need to know that sum of the zeros, when we have our quadratic polynomial ax square plus bx plus c, then sum of zeros which we can write as alpha plus beta as minus b by a, that is minus coefficient of x by coefficient of x square, and product of zeros as alpha beta as c by a, which is constant by coefficient of x square. So along with this, we also need to know sum of the zeros is minus b by a and product of the zeros is c by a. Now let's see how we can find alpha square plus beta square. So from this, since we have the polynomial 6x square minus 5x plus 1, alpha and beta are zeros of this, right? So here from this we can write alpha plus beta as minus b by a, so it will be 5 by 6. So this is sum of the zeros, and product of the zeros alpha beta will be c by a, which is 1 by 6. We want alpha square plus beta square. So alpha square plus beta square, we have to express this alpha square plus beta square in terms of only sum of the roots and product of the roots. No other term should be there in our expansion, in our simplification. Now in fact this is in the form of a square plus b square. We know that a plus b whole square is equal to a square plus b square plus 2ab, or a square plus 2ab plus b square. If we want a square plus b square, so we can transpose 2ab other side, will have a plus b whole square minus 2ab. Same thing in place of a and b, we have alpha and beta. So we can write alpha square plus beta square as alpha plus beta whole square minus 2 alpha beta. That simplifies to alpha square plus beta square. We have the value of alpha plus beta as 5 by 6, and alpha beta is 1 by 6. So substitute, we get the value of alpha square plus beta square. So 5 by 6 whole square minus 2 into alpha beta is 1 by 6. This will be 25 by 36 minus 2 by 6, or you can simplify to 1 by 3 also. So if we take LCM, it will be simplified to 25 minus 12, which will be 13 by 36. So this is our alpha square plus beta square. Then alpha square beta square also we need, because we need to write the equation as polynomial as alpha square beta square into x plus alpha square beta square. So alpha square beta square can be written as alpha beta whole square. And we know what is alpha beta, which is CB 1 by 6. 1 by 6 whole square, which is 1 by 36. Now we know the value of alpha square plus beta square. We know the value of alpha square beta square. Now substitute it here. Then the required polynomial is, then the required quadratic polynomial, so k into, your k can be any constant, x square minus of alpha square plus beta square into x, 13 by 36x plus alpha beta, which is 1 by 36. Again same thing, we can take 36 outside, we can take 36 LCM and then outside, so we'll get 36x square minus 13x plus 1. If we have k is equal to 36, then our required polynomial would be 36x square minus 13x plus 1. So this should be our final answer. So which is same in both the cases. Hope both the methods are clear. Whichever you feel comfortable, you can follow that. Okay. So only the change for both the methods is how you are finding alpha square plus beta square value and alpha square beta square value. Here using identities we are finding alpha square plus beta square value, and the first method we factorized and then found the values of alpha beta, then directly squared them, then found the sum and the product. Okay, that's all in this video. We'll continue in the next video the remaining questions. Thank you.